Question 8 asks, how can kinase cascades be reversed or turned off? All right, well, very simply, the most immediate answer to this, if we have phosphorylated proteins, so our kinases generally become active when they're phosphorylated. All right, the way that we can turn them off is by dephosphorylating them. And dephosphorylation occurs by the action of phosphatase enzymes. So phosphatase enzymes are very often used to turn off kinase cascades. Right, so now phosphatases will immediately deactivate the kinases, or they're kind of the closest way of turning it off. But at the same time, if the upstream molecules, for instance, some of the second messenger proteins, or maybe there's a GTPase, it depends on what type of pathway we're talking about. But there's almost always certain proteins or molecules that are initiating that kinase cascade, right? Well, those also have to be turned off. So, for instance, in the heterotrimeric G protein example, all right, well, in order to basically shut down the kinase, protein kinase A fully, yes, it must be dephosphorylated, but at the same time, the regulatory subunits has to reassociate with the kinase. And the only way that happens is if cyclic AMP is turned back into AMP. Right, and that is carried out by the enzyme cyclic AMP phosphodiesterase. Right, in the case of the receptor tyrosine kinase cascade that we've discussed, that's dependent on human growth hormone. In that particular pathway, the first kinases are activated and turned on by active RAS protein, right? Well, RAS is a GTPase, so it is in its active form when it has a GTP bound. Well, the way RAS gets turned off is by hydrolysis of the GTP into GDP and phosphate. Right? And this basically resets RAS and turns it off. Right? And so that's it for number 8. Basically, the kinases themselves get turned off by phosphatases. And in order to fully deactivate the kinase cascade, we also have to reverse some of the upstream events, for instance, cyclic AMP production or G protein activation that has to be reversed by hydrolysis of the GTP. That is it for number 8.